We're going to look at section 3.5 today, which is logarithmic equations. This is our bell ringer. See if you can pause the video, try these four, and notice it says do it without using a calculator, and then hit play and I'll show you how to do each one. Alright, so for number 1 and number 4, they both have log. Let me make that a little bigger. They both say log and then 10. But notice there's no base given. Well, whenever I have a log with no base, by default the base is 10. So for number 1 and number 4, they're both base of 10. But it's a base and that number, so what this is saying is that 10 to what exponent gives me 10 to whatever's there. For number 1, it's a 2. Well, 10 to what exponent gives me 10 to the second power? Well, 2. 10 to the second power gives me 10 to the second power. Easiest way of thinking about this is probably to say those cancel out and I'm left with the exponent. So when the bases are the same, 2. So for number 4, the base is 10, 10 and 10 cancel out, negative 3. For the other two, they say ln. Well, ln is the same thing as log base e. Well, that means the base is e, the base is e, e's cancel out, and I got 3. E's cancel out, negative 2. So whenever I have natural log of e, it's just the exponent. Whenever I have just log base 10 of 10, the answer is just the exponent. Alright, so moving on to our heading for today. This is 3.5, solving exponential and logarithmic equations. Alright, so these are a list of properties you need to know. So I would suggest pausing the video and writing these down in your notes. You need these. And then I'm going to talk about what they are. Alright, so when I have log of any base, doesn't matter what the base is, of two things multiplied together, I can break that into two different logs, both having the same base that I started with, and because it was multiplied here, we have addition there. Okay, and I'm allowed to go back and forth, so I can go from two logs added to combining them into one log with multiplication, or vice versa. If I have division, like I have right here, then I can break it into two logs with subtraction. The top one first, the bottom one is the one being subtracted. Alright, our third rule is I have a log of something to a power. I'm allowed to take that power and move it out front, like that. Okay, and then vice versa, I could take that number out front and move it to the exponent. Whenever I have log of 1, any log, like me natural log, doesn't matter what the base is. Whenever I have log of 1, the answer is always 0. Log of 1 is always 0. Whenever the bases are the same, now really 5 and 6 are the same rule. Whenever the bases are the same, the answer is the exponent. If there's no exponent, that means the exponent is a 1, and the answer would be 1. If there's an exponent other than 1, it's still just whatever the exponent is. So when the bases are the same, the answer is just the exponent. Exactly what we did on our bell ringer. If I have if I have a base to an exponent that's being added, I can write this as two different bases being multiplied. Alright, and that may look confusing, but you actually do this a lot. So if I have x squared times x cubed, well, that's the same thing as x to the 2 plus 3, or fifth. We add exponents. That's all that rule is saying. Likewise, if I have x cubed divided by x squared, well, then you would subtract those exponents, give me 3 minus 2, which is 1. That's what those rules are saying. If you have x squared cubed, well, that's the same thing as x squared times x squared times x squared, or the same thing as x to the 2 times 3, or x to the 6th. That's what this rule is saying. Anything to the 0 power is 1. And of course, if the exponent is 1, I don't actually have to write it. So, and then I have no idea why they bothered with that one. Yeah. All right, moving on. So here's some rules. If I have an exponential equation, we want to get the base with the variable exponent by itself, and then we're going to change it to log form, and then we're going to solve for the variable. All right, so let's look at an example of this. I'll move this here, change so I can write on it. All right, so here is my base with an exponent. I want to get that by itself. Well, to get it by itself, I need to divide by 7 from both sides, and then I get e to the negative 4v is equal to 53 over 7. Now I need to change it to log form, so I'm going to say log base e of 53 over 7 is equal to negative 4v. And then I want that v by itself, so I'm going to divide both of these by negative 4. And I really should have bothered to grab a calculator, so hold on one second. Alright, so I thought I was going to be able to use the calculator on the screen, but I can't when I'm writing on the screen, so I have to go grab a calculator. So let's see here, if I plug this in as a fraction, I'm going to put log on top, base e, and actually remember that this, I should write this out, is the same thing, log base e is the same thing as natural log of 53 over 7 divided by negative 4, okay? So 2 different ways I could type that. So I'm going to use natural log. And 53 divided by 7. And then all of that's being divided by negative 4. And I'm going to get negative 0.5061. Alright. If I try number 2, here's what I want by itself, and I have that minus 6 there, so I'm going to add 6 to both sides. 9 to the negative 4n equals 26 plus 6 is 32. Change to log form. Log base 9 of 32 equals negative 4n, and then divide by negative 4. If I type this in, I got log base 9 of 32 divided by negative 4, and I get n equals negative 0.3943. Okay. How many decimal places did they round to? Yep, they did round to 4 decimal places. Alright, so turn that off. Go ahead and try numbers 3 and 4, and when you're done I'll show you the answers to those and we'll move on to the next part. So go ahead and pause the video now. Alright, so the answers to 3 and 4 are negative 3.2093 and negative 0.2271. Alright. So that's if I had an exponential equation. If I have a logarithmic equation, well, we have some cases. So first case is, well, what if we have log equals a number? Well, if I have log equals a number, I just get the log by itself and change the form, change its exponential form. If I have log equals log, my logs cancel out. If I have log plus log equals a number, I'm going to combine my logs and then change the form. Sorry, move this out of the way. If I have log plus log equals a log, I'm going to combine the two logs on the left and then cancel my logs out. Alright, if that sounds like a lot, don't worry, we're going to do some examples. So, let's come back right here and let's look at these. Alright, for both of these, I have log equals a log. Alright, log equals log is probably our easiest case. We're just going to cancel our logs out. And I will show you the long way of why I'm allowed to cancel my logs out. Technically what I'm doing is I'm raising both sides as exponents of 7. Okay, I didn't pick 7 randomly, I picked it because there's the base. And remember, if my bases are the same, the answer is just what's inside. Okay, but that sometimes confuses people, so the easier way of thinking about it is if I have log equals log, the bases are the same, cancel my logs out, and I get negative 3b equals negative 5b minus 1. Add 5b to both sides. Divide by 2. And I get negative 1/2. Alright, go ahead and try number 6. Alright, so negative 1/2 and 6 is negative 6/7. Okay, I will move on to number 8 and 9. So in this case, I have log equals a number. And so if I have log equals a number, I get the log by itself and then change the form. So I need to divide by that 5. So that 5 is what's attached over here. Divide by the 5. Get log base 6 in plus 10 equals negative 1. So I got the log by itself. Now we're going to change the form to exponential. 6 to the negative 1 equals n plus 10. 6 to the negative 1 is just 1 over 6. If I subtract 10 from both sides, well, 1 over 6 minus, if I do 10 with an exponent of 6, I get 60 over 6, which is negative 59 over 6. Alright, go ahead and try number 9. Alright, so the logs here, I need to get rid of that minus 2, so we're going to add 2 to both sides. I get log base 9 n plus 9 equals negative 1. Change the form. 9 to the negative 1 equals n plus 9. Subtract 9 from both sides. Of course, 9 to the negative 1 is 1 over 9 minus 9 times 9 is 81, so this is 81 over 9. And that would give me 1 minus 81 is negative 80 over 9. Okay. Alright, we come to problems like 11 and 12. Well, this is if I have two logs added together. One has two logs equal a number, one has two logs equal a log. So we're going to do both of these. I'm going to add my two logs together, get log base 7. Of course, when I add two logs together, I multiply. 8 times x plus 1, okay, equals 2. I could go ahead and distribute the 8 now or wait. I'm just going to wait. If I do it now, it'll still be perfectly fine. So I change the form. 7 to the second power equals 8 times x plus 1. Now I'm going to go ahead and distribute it. I should have probably went ahead and wrote that 7 squared is 49. Subtract 1. 48 equals 8x. Divide by 8. And then let's see here. I know 8 goes in 45 times, so x, oops, let's change that to color, equals 6. Alright, log base 8 of 5 plus log base 8 of x minus 7 equals log base 8 of 79. So I have a log plus a log. So anytime I have a log plus a log, I'm going to combine. So, and this time I'm just going to go ahead and distribute them at the beginning. 5x minus 35. Didn't matter if I distribute them beginning or weighted. It'd be the same either way. Log base 8, 79. Well, now I have a log equals a log. We came to that case a few problems ago. We just cancel our logs out. Add 35. Alright, let's see here. 79 plus 35, 7 plus 30 is 114. And I get x equals 114, sorry. Over 5. Alright, go ahead and try number 13 and 14 on your own. Go ahead and pause the video and I'll show the answer. Alright, the answers 13, 14 are 33 over 4. And number 14 ended up being a quadratic, so you should have gotten both positive and negative 1. So you should have done a square root. When we do a square root, we put the plus or minus. Alright, we'll do one like this. We didn't do one. That was subtraction. So I'm going to combine my two logs and say log base 9 and subtraction, so I'm using division. 4x squared divided by 8 equals 4. And then I have log equals a number, so I'm going to change the form. 9 to the 4th power equals 4x squared over 8. Okay, so I'll pull out my calculator and say, well, 9 to the 4th power is 6561, and this is really x squared divided by 2, because I can simplify 4 over 8 to be divided by 2. I'm going to multiply both sides by 2, so that I get the x squared by itself. That gives me 13122 equals x squared. Take the square root of both sides. And that appears to be just, we'll leave it, x equals plus or minus square root of 13122, or if you put it in decimal form, still plus or minus 114.3 5, 5. I'm not sure how they left their answer. Alright, go ahead and try number 16. Alright, let's see how we did. Alright, oh, and apparently I could have simplified the square root that I did earlier, where I made a arithmetic mistake, and number 16 came out to be 4 and negative 4. Alright, I'm going to pause the video right here, and I'll have a separate video for these problems.